Hello and welcome to Pursuit of Perfect Systems video show coverage for the Festival of Sound, Music and Audio show. We'd like to thank our show coverage sponsors, Tellurium Q Cables, for helping us make this show coverage possible.
But we can't get anywhere with a hi-fi system without speakers. Luke, Wilson Benesch are a really famous company. I think whenever I make a video on them, people are always really interested and they always get loads of views. I don't know if that's because it's unique designs or just a really interesting design philosophy where you have the speakers facing out of the cabinet. So tell us a bit about maybe these speakers and maybe Wilson Benesch in general, please.
Thank you very much for your kind comments there. Wilson Benesch. We're celebrating our 30th anniversary next year, in 2019, so quite a big landmark date for the company. Yeah. We are a family-owned business, entirely private-owned, so we've developed over the years a very kind of comprehensive body of research into material science and essentially what impacts materials have within our loudspeakers, turntables and hi-fi rack designs. Principally, we've become, I think, the preeminent company in terms of our understanding of the use of carbon fibre composites. This is a resolution loudspeaker. It's a product that sits somewhere in the middle of our reference line, the Geometry series. It's £35,000 UK retail, and as you can see, it's carbon fibre top. What you probably can't make out, or your viewers can't make out at the moment, is the fact that it's got a curved carbon fibre monocoque, which we call the Advanced Composite Technology, or ACT monocoque.
So is that basically moulded in a mould?
That's correct, yes. Oh, right. So all of the application of carbon fibre composites that we do is never about a flat panel veneer of carbon fibre, which is what I think many of our contemporaries in the industry tend to apply. It's not a stick-on veneer or a flat sheet. It's about being able to manipulate the material and form the material in a way that basically extracts the maximum benefits of that material. And carbon fibre is principally known as a very, very stiff material, very light material, but it's also actually got very good damping properties, especially when you form it into a composite. That's because it's formed from billions of tiny little fibres, so you imagine all of those fibres essentially form a barrier to energy transferring through the material, but also out of the material and into the environment in this case, because we've obviously formed an enclosure from it. But composites, what you're trying to do is you're trying to get the benefits of multiple different materials that come together. So with our enclosure, the ACT monocoque, we're not just using carbon fibre, but as you say, we're laying up and moulding carbon fibre. There's a natural fibre material in there as well, and a core material which is actually used normally within aircraft luggage holds. So essentially used for absorbing, hopefully not, small explosive devices, the blast from a small explosive device. So what this is basically doing, it's like a honeycomb material that's basically full of tiny little air holes, and when you tap on it, it's very inert. It doesn't resonate at all, and so by combining and fusing carbon fibre with that, you're basically able to create a structure which is, in our view, it's class leading in the industry in terms of signal to noise ratio. So what you then have is a very inert loudspeaker cabinet that doesn't really make any, it doesn't leave a sonic signature within the environment. And we then couple that with our own drive technologies. So these are drive technologies that have all been developed in-house at Wilson Benesch, hand-built, and it's entirely proprietary to our company. So the latest generation is the Tactic 2 drive unit, which is what you see here. And we also make our own tweeters as well. This is a hybrid design. You guessed it, carbon fibre combined with silk. So it's a silk dome. So it's neither a soft dome nor a hard dome technology. Hard dome technologies are associated with very, very high bandwidth, wide bandwidth, 50 kilohertz and up. This is 30 kilohertz flat, it will reproduce to, And the reason why we want to combine that again with something that is a softer material like silk is because we value that kind of natural presentation within the sound that our loudspeakers make, and I think that's something that is really palpable and tangible when people listen to our products. There's a very open, natural character, very balanced character. I don't feel that they emphasise any one particular frequency band at all, which is what you would surely hope, because what you're trying to do is recreate the event as it happened, not an impression of the event according to how that loudspeaker might sound.
So those parts are chosen not just because of technical reasons, but for audio reasons, actually based on listening tests.
Yeah, all of our products are voiced extensively over long periods of time. So this kind of approach within what we've done with the semi-sphere tweeter in terms of the material uses is also, it's been informed by what we've done with the drive technology. So in the Tactic 2 drive unit, we're using an isotactic polypropylene drive unit cone. Now that is something that is increasingly used in the industry and is seen now as kind of fairly commonplace, but actually we developed that technology in the late 90s with Professor Ian Ward, who was actually the chemist who essentially, it wasn't all of his work that brought this material to the world, but it was his work that allowed it to be commercially viable to make products from it. And this was actually the first commercially available product in the world to use that material. You'll now see that material being used in Samsonite suitcases, which doesn't sound very exotic, but when you actually think about what you're trying to do there, you're trying to create something that is stiff but also very well damped, so that it will absorb energy when someone throws it off a plane and it doesn't damage all of your stuff inside of it. So again, what we're doing here is we're trying to find a synthesis of stiffness and damping, a balance.
Yeah.
There is compromise in design, whatever you do, whatever approach you take. There are always compromises, and you have to choose which ones that you're going to accept as part of the design. But with a drive unit, you're trying to create pistonic-like response so that you can compress the air and create sound waves. And in doing that, therefore, you need stiffness so that you can move the drive unit without the whole thing flopping around. But create something too stiff, and then you get that very sibilant nature to the sound reproduction, and it doesn't sound somehow quite natural. It may grab you at first, but in our humble opinion, we believe that over long periods of time, hard dome technologies, be it in the tweeter or in the drive units, don't create that long-term satisfaction and emotional connection with the musical piece that you're listening to.
So besides looking really cool, why do you have kind of rear-facing drivers in the speakers? They do look really cool, but there must be another reason for it.
Okay, yeah, absolutely. So again, fairly unique approach to design of a loudspeaker, low frequency or bass woofer. We are doing this because what we, well, I suppose the good place to start is probably what we call it. We call it the isobaric drive system. Now, isobaric was this formation of loudspeaker design was not created by Wilson Benesch at all, but it's something that we've now used since the launch of our product called Bishop, which was, I think, in 1999. Obviously, it was body research that went before that, but we've used this subsequently in other designs, both in the clamshell formation, which is what you see here, where you've got the two drive units in a push-pull formation. So there's one drive unit on the inside of this and one on the outside. So it's like a mirror almost, a mirror image. But we also do the other version, which is what we call a line astern version, which is where the two drive units line up almost like cars on a Formula One grid, for example. So one behind the other. But what we're doing here is we're using two drive units to basically perform the role of one. So we're dividing the load upon a bass drive unit in half and sharing it across the two drive units. So rather than using a large 14-inch woofer, we're sticking with a 7-inch woofer, which is then common across the whole of the speaker design. So this drive unit and that drive unit are essentially identical. I mean, we make 25 different iterations of that particular drive unit, but principally the design is based around the same form factor. And what we can achieve, therefore, is very quick, very dynamic, very punchy bass. The timing of it is right on the money every time, and that is, in our view, very, very important, because you're trying to create integration between your low frequency response, your mid-range, and your upper frequency. And And if your bass is out of time with your mid-range, everything is smeared, and all of a sudden the whole thing, the magic show, is over. Everyone sees that it's a loudspeaker, or hears that it's a loudspeaker, and not in fact a very, very tight drum solo. So it's physics. You know, if you imagine a 14-inch woofer compared to a 7-inch woofer, you're talking about moving mass. So if you imagine a large sports car, heavy, it'd slow down the straights, slow into the corners, and slow out the corners. You reduce the mass, increase the stiffness, as we've done with various parts of the cabinet, but if you reduce the mass, you're faster down the straights, faster into the corners, you're faster out. So it's all about timing and integration, and timing is absolutely critical in everything in audio. So
one more question, Luke. Why I'm going to call it an alien head on top, or a crown? You could call it a different thing. Why that shape on top? Is that just for looks, or is it?
No, absolutely not. Nothing we do is about aesthetics. Of course it is. It's very sculptural form. Okay, so perhaps a little bit of a background about the company. My father, who's the designer, so there's actually 3 family members in the company. There's my mother, Christina Milnes, who's the managing director. There's my father, who's the design director, and myself, who's now international sales and marketing. But in terms of how the product looks, it's informed by the background from which the person who designs them comes from. So my father was an apprentice within the British Steel Corporation originally. We're obviously a company from Sheffield, so a long history of steel manufacturing and production. And so he came from a long line of engineers within his family, but he studied fine art and sculpture. So you'll see the sculptural form is evident, and right across our product lines you see that. But the reason we're using it is because, well, when we came to the industry, the standard ubiquitous shape within the industry of a loudspeaker was a rectilinear box, square on all surfaces. Within any structure, if you're trying to impart stiffness, you generally want to avoid something that is flat, and you want to create a curve, because curves are inherently strong and stiff. So we're creating these curved forms to increase the stiffness of the cabinet, and this is the reason why we're using this curve across the back of the speaker as well. But not only that, in terms of how flat surfaces and curved surfaces behave when they are subjected to sound hitting or leaving that surface, it's akin to looking in a mirror. If you look in a mirror, you get a direct reflection. Within an audio environment, what you're trying to do is make this disappear, like stealth. You don't want to listen to the speaker, you want to listen to the music. So in order to create that subterfuge and make the speaker disappear, what you're trying to do is reduce the sound coloration from that as much as possible, be it from any sound that is escaping from the cabinet itself, or indeed from reflections within the room that are actually hitting that cabinet and reflecting off it. So if you create a wide range of angles and complex shapes, what you're able to do then is make the speaker essentially disappear, because you're not getting any one single reflection that you go, I can hear the speaker resonating, or I can hear a reflection from somewhere around the system. And by creating such a complex form as that, what you're doing is you're throwing out all of that energy like this, rather than like this. That's why we're doing it.
The speaker's an acoustic diffuser in itself. What an amazing idea! I've never ever thought of that. What an amazing idea.
I think, although I was not here to see this because I was probably only 7 or 8 years old when we first launched our first loudspeaker, but my understanding is that the sloped top in a loudspeaker design, we were the first company in the world to do that. The first product we launched as a loudspeaker would have been the ACT 1 loudspeaker, which was 1991, and again it had a curved composite ACT monocoque on the back. So we were working with carbon fibre in the late 80s, and there were seldom any commercially available products that were using this kind of technology then, and we're still using it now, and we're using it for all the right reasons, none of the wrong ones.
Well, it's amazingly interesting, Luke. What you just explained there is really interesting.
Thank you.
People would never know that, I don't think. I didn't know it. You sort of think if I don't know it means no one else does. Because I know everything. So thank you very much. Really, really insightful. Okay. And I can't wait to listen. Thank you very much.
Thank you very much.
Thank you.
Cheers.
Cool.